In problem 4, we're going to compute a 98% confidence interval estimate for the population mean of hours per charge after the flashlight has been recharged overnight. The sample size is 36. The sample mean is 2.69. And the sample standard deviation is 1.4. Now, why do I know this is the sample standard deviation and not the population standard deviation? Well, the sentence that this phrase, standard deviation, appears in begins with the random sample yielded a mean of 2.69 hours and a standard deviation of 1.4 hours. So this is a sigma unknown problem because we're not given the population standard deviation sigma, we're given the sample standard deviation, in this case 1.4 hours. So I'm going to copy these things, these values. So my n is 36, x bar is 2.69, s, the sample standard deviation, is 1.4, and 1 minus alpha, the confidence level, is 0.98. I've done that here. I have a sample mean of 2.69, a sample standard deviation of 1.4, a sample size of 36, and a confidence level of 0.98. The sample variance is the square of the sample standard deviation. The variance of the sample mean is different from the variance of the variable. The variance of the variable from the sample is 1.96. The variance of the sample mean is the sample variance divided by the sample size. The standard error of the sample mean is the square root of the variance of the sample mean. Next, we're going to compute the margin of error. Now, because sigma is unknown here, we have to use estimates of sigma. We have to use an estimate of sigma. In this case, we're going to use the sample standard deviation as an estimate for the thing that we cannot know, sigma. And for that reason, we have to use a confidence interval that replaces t with z in the margin of error and sigma with s in the margin of error. Now, this right here is the estimate of the standard error, or the estimated standard error, and multiplying that by t gives us the estimated margin of error. So it's very similar to a sigma known problem, but instead of using sigma, we use s, and instead of using z, we use t. Now, the confidence level is 0.98, so that means that the significance level is 0.02 because the confidence interval has two values, an upper value and a lower value, a lower tail and an upper tail. We have to divide the significance level by 2. The t value comes from a t distribution. There are infinite many t distributions, all with a center at 0. The thing that distinguishes each t distribution from other t distributions is the parameter called degrees of freedom. It equals n minus 1 in this case. So the degrees of freedom are 35. We have to go to row 35 of the table of t distributions, and then we're in column 0.01. We can access the t distribution from my teaching website. Then we'll scroll through the standard normal tables to the t distribution table, and then to row, which corresponds to degrees of freedom, row 35. Now, the column was, again, 0.01, and the row is 35. So in column 0.01 and row 35, we get a critical value of 2.438. We're going to copy that and paste that into Excel here. Now the margin of error is the estimated standard error times the t-value. So all we have to do is multiply the t-value times the standard error, and we get 0.569. To compute the confidence interval, we take the sample mean and we subtract from it the margin of error first, and then we take the sample mean and add to it the margin of error. So the sample mean minus the margin of error, and then the sample mean plus the margin of error. So the 98% confidence interval is 2.12 hours to 3.26 hours. And notice that 2.5 hours, the advertised value, is inside the 98% confidence interval. So we're 98% confident the true population mean, mu, which we cannot know, is inside these two values. The 98% confidence interval, the reason why we say that is because the population mean is either in an interval, in which case the probability would be 1, or the probability of the mean, the true mean, being inside this interval is 0, because it's not in the interval. The reason why we say we're 98% confident is because if we construct 1,000 confidence intervals from 1,000 unique samples of size 36, 980 of those confidence intervals will contain the true population mean, mu, and 20 will not. Next, we're going to copy this information into Cengage Now. So let's go back to Cengage Now. We need to get the point estimate of the population mean. Well, that is just the sample mean, x bar. The standard error equals 0.233 to 3 decimal places. Part A was to 3 decimal places, so we're going to add a 0. To compute the margin of error, the standard error is multiplied by the critical value. The critical value for the confidence interval can be found we found it in row 35 of the t-table. And the critical value was 2.438. Next, we have to enter the margin of error that we computed from Excel, and it was 0.569. And then the confidence interval has two numbers, the lower confidence level and the upper confidence level, and both have to be to 2 decimal places. And we have those in the Excel spreadsheet as well. So the lower confidence level is 2.12, and the upper is 3.26. And then I'm going to check my work, and we should get everything correct. And we do. The advertised claim of the flashlight lasting up to 2.5 hours, that value, 2.5 hours, is inside our confidence interval. So we are 98% confident that our advertised claim of 2.5 hours per charge is accurate.